section 10.7. So this is the last section of chapter 10, which means you should be looking for your chapter 10 test. You guys need to get your homework and your tests in, okay? All right, last section of chapter 10 is a locus, okay? So a locus is really, it's a broad definition. So what it's referring to is all points in a plane that satisfy a given set of conditions. Okay, so you have one locus. And if you have more than one, plural of locus is a loci. So L-O-C-I, okay? So generally you describe a locus as the path a moving object takes, okay? So with a locus, okay, let's go over one first and then we'll kind of go more in depth a little bit. So to see how it works, right? Start by drawing a line on a piece of paper. Doesn't matter what the line looks like, just any line. Okay, we're gonna name it line K. So here is my line K. We're looking to draw and describe the locus of points that are 1 inch from line K. All right, so where would be 1 point? So remember that measuring the distance between a line and a point is perpendicular. So I would go down here and I'd measure an inch and say, here's a point. Then it has to be perpendicular and it's going to be an inch. Here's another point. Here's another point. These are all points that are 1 inch from K. But then we say, is that all points that are an inch from K? And they're not really, okay? I can have points up here. So here's a point that would be 1 inch from K. Here's another point. Here's another point, okay? So all these points on this line and this line would be 1 inch away from K. So we're gonna describe it as 2 lines. Well, what do we notice about these 2 lines? Because they have to be an inch away, they're never going to intersect line K. So that means that 2 lines that are parallel to K and 1 inch from K would be how we would describe the locus of points that satisfy that given condition. Okay, any points on these 2 lines are 1 inch away from line K. So how do we go about finding a locus? Okay, so to do that, what you first start with is you're going to draw any figures that are in the given statement. Okay, just like a proof, start with what's given to you. Okay, then you're going to start locating several points that satisfy the given condition. And you continue finding points that satisfy the given condition until you find a pattern. Okay, and then finally you can draw and describe it. You always want to describe your points in words too. Not just a drawing, you want to explain what it's going to look like. Okay, and when you have more than one given condition, first you find all points that satisfy each condition separately, and then find where those points intersect. Okay, So we're going to start with a triangle. So triangle ABC. Doesn't say what the triangle looks like. It just says given triangle ABC. Okay, so here is my triangle ABC. I'm going to start with the given. Okay, you want to find the locus of points that are equidistant from AB and line segment AC, and equidistant from A and B. Okay, so we have two conditions that we want to satisfy. So we're going to start with the first one. Points that are equidistant from two lines. Okay, so here's AB and here's AC. So for example, point A would be equidistant from those two lines because it's on the endpoint of both of them. Okay, then another point would be here, here, here. Okay, so any points along this line satisfy the first given condition, and that's all points that are on the angle bisector of angle A. Okay, so these are points that satisfy the first condition. Then our second condition says points that are equidistant from A and B. So here's A and here's B. So the first point that's equidistant is the midpoint of that line. Okay, and then we have a theorem that tells us that any point on the perpendicular bisector of a line are equidistant from the endpoints. So any point along here satisfied the second given condition. Okay, so then we want points that are satisfying both of these conditions. So it ends up being the one point right here. It's a loci because there's more than one given condition. It's a point where the angle bisector and the perpendicular bisector intersect. Okay, so we satisfied both conditions, and then we see where they overlap. All right. The second one is saying to find the locus of points that are 2 centimeters from point X and 3 centimeters from point Y. Okay. So what you're given is you're given 2 points. You don't know exactly where those 2 points are, so they could be anywhere. Okay, so if point X is here and point Y is here, okay, you want points that are 2 centimeters from X. So that's going to be, here's one point, here's another point, here's another point, here's another point. So it ends up being a circle around X. Okay? Imagine that's round, like in your notes. And then points that are 3 centimeters from Y. So if I measure out 3 centimeters, right, so this is 2 centimeters. If I measure out 3 centimeters, I also get a circle. Okay? But, so we can describe it this way, right? The locus that's 2 centimeters from X is a circle with radius equals to 2, center at X. Okay? And the locus that's 3 centimeters from Y is again a circle with a radius of 3 and center at Y. So you're looking for points that satisfy both conditions, okay? but it depends on where point X and Y are, right? So if, when you look at your notes, okay, if X and Y are more than 5 centimeters apart, right, because here's 2 centimeters, here's 3 centimeters. So that means that these are more than 5 apart here. You have no points in your locus. But if X and Y end up being exactly 5 centimeters apart, right? So 2 centimeters and then 3 centimeters, so 5 centimeters, you get 1 point in your locus, okay? And if X and Y are less than 5 centimeters apart, okay, you'd get 2 centimeters and then 3 centimeters. So you'd end up having 2 points in your locus. And that's exactly how we would describe it. We'd have to write that out. If it's more than, if it's equal to, or if it's less than, and describe what those points look like. Okay? So with a locus, you just have to satisfy given conditions. Okay? So again, kind of like a proof, start with what's given. It's going to be a figure. And then describe the pattern that comes from that given statement. Okay? And the given conditions.